Okay, so in this video, we're going to be looking at parametric equations. So in maths, all this time we've been looking at equations where we have y as a function of x, such as y is x, y is sine x, y is x squared. This particular form is known as a Cartesian equation. But now we're going to be looking at how x and y, when they're not linked, when they're linked by a new variable, such as like t, mostly this is t, but sometimes you might give it as k or even like theta, it doesn't really matter. These are known as parametric equations. So these equations look at how x themselves are changing and how y themselves are changing and when they're not related to each other whatsoever. And so there are a couple of questions or they can ask you about this, and they can ask you, how do we go from a parametric equation to a Cartesian equation? And so the way we do that is just by substitution. So we would rearrange for a certain variable and then substitute from one to the other to get y in terms of x. We'll look at an example later on. Other stuff, or two other key points that you also need to know, is the ranges and domain. So the domain of the function just represents just what the x values will be, right? So that's going to be equal to the range of the parametric function of x, in this case p of t. Because this x is p of t just tells us how x changes, right? What x is, the lowest one, the highest one. So it just tells us what the possible x values are, which is just a definition of the domain. The range of the Cartesian function, in this case, is actually equal to the range of the parametric y equation. But it's the same reason, because this equation here tells us how y changes, what the y values can take, which is a definition of the range of the Cartesian equation. And from that, we can answer a lot of different questions concerning these types of parametric equations. Right, let's take a look at a question. So we have a curve C, and it has parametric equations. X is 3 over t plus 2, y is 2t minus 3t minus t squared, where t is all real numbers and t is not equal to 0. So they've given us the domain of t. This is not the domain of the Cartesian, okay? So don't get confused with that. So in part A, they're asking, determine the ranges of x and y in the given domain of t. So the reason why sketching graphs is so important is because in this certain case, it allows us to sketch these parametric graphs just so we can actually visualize what the x values can take and what the y values can take as well. So make sure you're up to scratch with all the different graph sketches that we've been learning throughout maths. So first things first, let's sketch the x is 3 over t plus 2. It's like a 1 over t graph, right? Or 1 over x graphs. And then we're adding 2, meaning that all the y values we moved up by 2. So in this case, we have the x-axis, and then we have the t-axis, and this will be when x is 2, and the graph will look something like this. And so they've said that t is not equal to 0, okay? So meaning that the possible x values, well, x can be all real numbers, except x cannot be equal to 2, because that's an asymptote, right? So this is technically the range of the parametric x, which in turn will become the domain of the Cartesian equation. Let's look at the range of y. So y is 2t minus 3 minus t squared, which we will try and sketch just to visualize it again. It's like a negative quadratic graph. So here is going to be negative 3. This will be t, this will be y. And for the domain of t is not equal to 0, then y can be all real numbers and y is also less than negative 3. So this is the range of the parametric y, which in turn becomes the range of the Cartesian equation. Okay, so this is the domain and this is the range here. Right, in part B, it says show that the Cartesian equation can be written in this form here. So Cartesian just means, once again, y as a function of x, meaning we want to get rid of the third variable, in this case the t. So what we want to do is substitute. So starting off with x is 3 over t plus 2, I want to rearrange it to make t the subject. So we'll have x minus 2 is equal to 3 over 2t. T is 3 over x minus 2. So we found t in terms of x, and we know that y is a function of t. So therefore, I can substitute this t into wherever the t's are in the y, and that way we can get rid of the t. So we'll have y is equal to 2, 3 over x minus 2, minus 3 over x minus 2, all squared. And technically this is the answer, this is a Cartesian equation, but it's in quite an ugly form, and they want it in a better form for us. So it's just a matter of simplifying it. So we can maybe make it into one fraction with x minus 2 squared on the denominator. We'll have 6 times x minus 2 minus 3 minus 9. we can expand, minus 3x minus 2 squared minus 9. We can expand 6x minus 12 minus 3x squared plus 12x, and then we'll have minus 12 minus 9 all over x minus 2 squared. Finally, just simplifying again, minus 3x squared plus 18x minus 12 minus 12 minus 9 is minus 33 over x minus 2 squared. I can take minus 3 out, x squared minus 6x plus 11. And this will be our Cartesian equation in the simplest form. So the last part is just simply expanding and simplifying. It's just the initial part where we have to substitute a t. That's important. That's how we get the Cartesian equations. Okay, let's just try one more question. So we have a parametric equation, x is ln t plus 3, and y is 1 over t plus 5, and the domain of t is bigger than negative 2. So it says show that the Cartesian equation is y in terms of f of x. So first things first, we have to get t in terms of x first, because that's what we're going to substitute with. So we have e to the x is t plus 3, so therefore t is e to the x minus 3. Now y is 1 over t plus 5, so we found our t, so we can substitute it in straight away. So we have 1 over e to the x minus 3 plus 5, which is y is equal to 1 over e to the x plus 2. This here is our Cartesian equation. So this part is fairly simple. They also want us to find the domain of the Cartesian, and in part B they want to find also a range, so we'll do that together. So once again, we know that the domain of the Cartesian is equal to the range of the parametric x. So for x is ln t plus 3, and t being bigger than negative 2. So that's why I said we need to be able to draw all different types of graphs, because this is an ln graph, right? So a ln graph, so we need to be able to sketch this as well. So we'll have t-axis, we'll have the x-axis. This is when t is negative 3, and it'll look something like this. Now, t itself has a domain, right? So t is bigger than negative 2, so negative 2 is here. So for x is going to be just bigger than 0. Right, for y was 1 over t plus 5. Once again, we do have to sketch this here. So it's going to have the t-axis here, the y-axis here. This is going to be t is negative 5. And it's going to look like this and here. But t is bigger than or negative 2. So negative 2 will give like 1 over 3. So what y can be is bigger than 0 and less than 1 over 3. So this here is the range of the parametric y, which is the range of the Cartesian. This here is the range of the parametric x, which is the domain of the Cartesian. And that's really about it for parametric equations. In the next video, we're going to be looking at dealing with parametric equations which have trig terms, but the concepts are always exactly the same.